Okay, so I guess this is 2.1 part 2, right? Sound good? So this part 2, we're going to talk about two important words when we talk about graphing. And those two important words are this one here, interpolate, okay? Interpolate, I-N-T-E-R-P-O-L-A-T-E, interpolate, and extrapolate, extrapolate. Now, the big difference between these two words is the first part, inter versus extra. This is how I remember how these words are different. Inter, if we have something inter, like an intermission, right? Or an interview or an inter something, that means inside of, right? Like it's a break in a game, an intermission. Or an interview is like you're brought inside the company and they want to see who you are and what you are. You're brought in. Okay, so interplay, that's play between members of whatever group. Extra means over and above. It's outside of, right? It's beyond. If you get extra credit, here's the credit in the course, and you can add on with extra stuff or whatever, right? A bonus question is extra. So extra is outside, inter is inside. So look at this example of a graph, okay? And this is the growth of a bean plant. So someone has grown a bean plant and plotted the lines, or plotted the points, after measurements of each week. Now, it appears that there is a missing point for week 4. Do you see this? There's no point here. There's no point anywhere. And David forgot to record the height of the bean plant on week 4. Use the graph to interpolate the height of the plant that week. So again, interpolate means that we look inside the points that we have plotted. So interpolate means within the data that we've taken, let's try and make a guess as to, what would be a point inside the data that we've taken. So where do you think, what would be your guess as the height of the bean plant? Like just a ballpark in week 4, yeah?
22.
About 22. Okay, so 22 would be right about here, and so you're saying right about there. Boy, that looks pretty good. Now, why wouldn't you pick 40? Why wouldn't you pick 40? Yeah?
Because the line doesn't reach up there.
Okay, so this little line here is a general pattern, right, between week 3 and week 5. And so the plant, I mean, we know how plants work too. This plant would not have shot up like this and then shrunk down and kept growing slightly. Like that doesn't make sense, right? And the plant could have had some kind of like stunted growth and maybe been closer to here. It could have been. And then took a real jump there in this next week. But you're right. The best guess would probably be right there in the middle, probably around, said about 22. That's perfect. That is interpolating. Okay, interpolating. To interpolate data. All right, so what might the height of the bean plant be in week 12? Okay, so now obviously week 12 is outside of the data that we've taken, right? So this would be an example of extrapolating, extrapolating. So it's not inside the points. We're not trying to judge what these values might be inside here, but instead we're kind of looking beyond. Now, what's the pattern leading up to week 12? Well, it looks like we've had some steady sort of growth here, but what's happened these last 2 weeks? It's kind of what? Yeah, it's kind of leveled off. So the plant seems to maybe have reached close to its sort of maximum height. So if we're looking at week 12, we're probably not going to say, oh, it's going to go up here. Yeah, that's the height right there. That's totally reasonable. The data doesn't seem to indicate that. As well, you're probably not going to go down here for week 12. No, you're probably going to just continue on with the pattern. And actually, I'll get rid of maybe some of this stuff here. Well, okay. So that you see it kind of goes like this, then like this. So your guess might be somewhere around this. And actually, maybe it's a little bit of a down trend there. Maybe it's starting to wilt a little bit. Who knows? Reach its maximum height. But maybe it's drying up and maybe it's starting to die now. I don't know. But it would be somewhere around maybe this point, right? 38 maybe, let's say. You see that? That would be totally reasonable. You got it? So there's interpolating, there's extrapolating. Write a statement describing the trends in the bean plant's growth rate from week 0 to 11. Okay. So what would the trend be? It looks like it grows fairly rapidly because this is a pretty steep region right here, isn't it? So it starts to grow fairly quickly, then has a rapid amount of growth. Then what happens to the growth rate from week 5 to maybe 9? What happens to the growth rate? Is it growing faster or a little bit slower than it was before? So compared to this growth rate right here, what do you think this growth rate would be?
Oh, it's slowing down.
Yeah, the growth rate is not as high, right? It's not growing as fast. And then obviously, maybe in this part right here, the growth rate is maybe 0. It's not growing at all. Okay? Does that make sense? Do you understand that? Okay. So that's like describing the trend growth rate. Okay. So here are the solutions there. So you can kind of see that. We're right on there. Okay. So let's do some questions then. Let's do number 7 together. Okay. Therese is on a road trip and is keeping track of her car's fuel consumption. The graph below shows the amount of gas in Therese's car at different times of the day. Use the graph to discuss what she may have been doing during the different time frames. Okay, so the amount of gas in her car. So the volume of gas in the tank is the left column. So at 0, she is completely empty of gas, right? At 50 liters appears to be, for this day anyways, the maximum amount that we have for the point. So what do you suppose is happening? What do you suppose is happening during this part right here? From about 8 a.m. to 11 a.m. What do you think is happening there? Mm-hmm.
Drive the kids around.
Okay, so driving around. Okay, so Therese is driving around, and the fuel in the car is going down. Now, what about here though? Like if we zoom in there, what about there? What's happening there?
It's just being moved.
Yeah, it seems like the car maybe isn't moving.
Maybe she went into the store.
Maybe she went into the store. Exactly. She spent an hour shopping. Okay, so she drove somewhere, right? And we could go even deeper than this. We could say, you know what? She used a lot of fuel in this first hour. So maybe she was driving around town. Maybe then she kind of got on the ring road, or she was on, driving out of town, used a little bit less fuel in this next hour, because you get a little bit better fuel economy in the highway. And then here, she didn't use any fuel this hour, so maybe she stopped to go shopping. That's an excellent assessment of what might have been happening here. Okay, so somewhere between 11 and 12, what seems to have happened here? My goodness, what do you think this is right there? What about over here? You guys haven't answered yet. Filled it up. Right. Okay, so the car is low on fuel, maybe at this point here about 18 liters or so. And then looks like it was filled up. Okay, and if this is filled up, what size is that tank? How many liters is that tank? Yeah, 50. Look at 50 right here. You guys are good. See? This is easy stuff, isn't it?
Yeah.
Yeah. Okay, so again, she drives somewhere here, uses about the same rate of fuel loss here, right? Same rate of fuel consumption. Then she stops again, uses a little bit more fuel, stops again. Okay. So you can describe probably some kind of situation here, but you hit the main points there. I think that's awesome. Okay? Any questions about that? Is there any part of that kind of doesn't make sense? Now I have a question. This line right here connects this point and this point. So at 11:30, what do you think? Because there's no point there. 11:30. So I'm just wondering, at 11:30, how much fuel do you think she had in her car and why? Go ahead. Yeah, you guys can both answer. Go. Okay. Sorry?
I think 35.
You think 35? Okay. So, so you think about 35 right about here. Okay, so that would be a reasonable interpolation. But if we think about the nature of the situation, how long does it take to fuel up your car? Does it take an hour to fuel up your car?
history stories
Maybe at a gas station that's really brutal, and the guy's like just like drip, 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 right? Okay. So it doesn't take an hour to fill your car. So do you think that she really did have 35 liters in her tank at 11:30 exactly? Well, if she started filling up her tank at 11 a.m. and took an hour to fill up her tank until exactly 12 p.m., then yes. But that's not probably reasonable, right? So in here, this is kind of the lost time here between 11 and 12. So check this out. It only takes 5 minutes to fill up your tank. So maybe she used a little bit of fuel to drive to the gas station, and then in the 5 minutes, she filled up her tank. Or maybe the tank was actually greater than 50 liters, and then she drove for half an hour, used a bunch of fuel, and so on, right? So we don't know actually what happens in between there, because it only takes 5 minutes to fill up your car. It doesn't take an hour. So it could have been right here. You could have been right, actually, right? But also, maybe she stopped. Watch this. Because we're only, where's the eraser? Because we're only taking measurements every hour, maybe this is where she stopped at the gas station. Maybe she stopped at the gas station for 2 minutes, and then somebody filled up her car, and by 11:10 or whatever, it was full. And then she sat there and ate lunch there or something, right? So we really don't know what happened in between here, but somewhere in there, her car got filled. We know that, right? You see where I'm getting at? Does this make sense, or is that kind of like goofy, loofy stuff? Does it make sense? Do you have a comment or a question? Yeah.
It might sound dumb. But
No dumb questions.
Is the dotted line is it like the gas going up or down
Okay.
when she's moving?
Is the dotted line the gas going up or down while she's moving? Okay, not necessarily moving. The dotted lines are kind of like they're not data points.
Okay.
It's just kind of the reason why it's dotted there is just so you can kind of like, in the big picture, see whether the points are moving up or down from each other.
So if she was driving, then it would be a solid line.
Yeah, if she was driving at a constant speed and there was a constant consumption, it might be a straight solid line, yes. If we were able to take the fuel level measurements every minute, then we would have a whole bunch of lines that we could, pretty conceivably draw a solid line in between. But because it's only measured every hour, we don't really know what's happening exactly. But yeah, so the dotted lines are not data points, they're just a general description of what's happening. Okay, those are great questions. I hope you guys are getting some answers here for those two. All right, so that was a question, right? So use the graph to discuss. Okay, so we just talked about this whole thing. She's driving, she's maybe stopping to shop or here or whatever. She's at the fuel station, filling up there somewhere, and then drives some more and maybe ends up home at 5 p.m. or whatever. Okay. All right, so that's up to you to kind of just to write that out. Let's talk about 8, and then I'll get you guys to, let's just talk about 8, and I'll give you a few minutes to do that on your own, see if you can get it. So lumber is often priced in board feet. A board foot is a piece of lumber 1 foot long by 1 foot wide by 1 inch thick. The graph below represents the cost per board foot of kiln-dried spruce over a period of 1 year. Okay, so the different months of the year, and this is the price. Okay, so there's a bit of a dip in, the first dip that we see here of the year is in May. All right, the price goes up a little bit in June, and then it steadily sort of declines. It appears to steadily decline until about November and December, and then goes back up again. So number A says, what's the general trend in the cost of this spruce? So what's the general trend from the beginning of the year, or let's say from March, okay, for the full year to February? What is the general trend? If you looked back, blurred your eyes, what do you think the general trend is? Or you can separate it into some parts. What would you say? You're taking your glasses off so you can literally blur your eyes? Okay. What do you think?
I think it would be slowly declining. Like it would go up a little bit, but then
Okay.
most of the graph is declining.
Okay, most of the graph seems to be declining. Now, we kind of end a little bit lower in February than we started in March. So you could say overall, the price declines throughout the year. Okay. You could say I would say this, because there's an obvious sort of section here. The price tends to decline a little bit from March to May, and then it rises in price in June or around the spring, summer time there, summer, and we'll talk about why that might be. And then steadily decreases until Christmas, before it picks back up a little bit again after Christmas or after December. So price goes down a bit and experiences a spike in the summer months, and then steadily goes down after that. Something like that, okay? You could do something like that. Now, why do you think it would take this spike here? And I think, okay, why do you think it would take this spike right about then? Yeah, go ahead. Mm-hmm. Kill.
Well, people aren't people aren't trying to build their decks in the winter time, so they're not buying wood.
Okay.
But they might buy wood in the summertime.
Awesome.
Because that's what they're going to use to make their patio. Or
Right. So you're saying, you first of all said it's low here because it's winter. They're not doing a whole lot of building outside because it's freezing cold.
Yeah.
And here, the price might be high because the demand might be high because people are building their decks and stuff, right? Awesome. So yeah, so when the demand is high, the price generally is a bit high. And when the demand is low, the price goes down because they usually have stuff that's sitting around. No one's buying. So they drop the price so people buy it. Okay, awesome. So that is great. Now the graph does not show the cost in August. Use the graph to interpolate the cost in August. So what do you think the August cost will, come on, eraser. What do you think the August cost would be? Okay, what do you think the cost would be there? About, okay, so this would be about 350, halfway between 300 and 400, this line right here. So you're saying it'd be about here, so about 325, 330, maybe? Maybe 325, 330, good. So that I think would be a great guess right around there. And it's pretty safe because, look at that. That's almost an exact straight line, those points that are immediately around that. So yeah, that would be a perfect guess. Okay. Okay, so based on the general trend in this data, what would you estimate the cost of kiln-dried spruce to be the following month? March. Okay. What? What would you estimate the cost? Okay. So what would you estimate the cost to be in the following month after this? So March over here of the next year from where we started. What would you think this would be over here? What would the cost? Somewhere around here? Or?
I think it would be near the exact same as the last price.
So you think it would be about near this one?
Yeah.
Okay. So let's take a look at this. These prices seem to be climbing. No indication that it might, change. So we'll keep on that trend, and it looks like it might be sort of around here, or it might be exactly where it was the last year. Maybe a little bit lower if you think, hey, throughout the year it's generally gone down. Might be a little bit lower, but it could be the exact same too. So yeah, that's good. Okay, so take a few minutes and you can just finish up writing your answers out there, okay? And then we'll move on to the last part. All right, example 4. So Brett is a real estate agent and is comparing the average listed price for houses in Vancouver to those in Regina from 2006 to 2010. Okay, so we have a chart here. Okay, one of the ways we can display data is in a chart. Now maybe it's not as quick and easy to see trends as a graph, but we could look and say, okay, in Regina we have a price in 2006 was 132,000, then 166, then 230, 230, and 232. So we can see that generally the price is increasing. It's held fairly constant from 2000 to 2010, really, right? A change of 2,000 is nothing much. So flattened out here. Increase, increase, flattened out a little bit. What about Vancouver? Well, we could see here in Vancouver that the price started quite a bit higher. The price was quite a bit higher than Regina. Okay, more people, lots more going on in Vancouver. Maybe it's a little bit limited with the landscape and stuff, the ocean and the mountains and whatever. But Vancouver is the price is really, really high, so quite a bit higher. But they did increase the next year, but then it dropped here. This dropped, right? And then went another big increase. So we can see kind of what's going on. So if we display the graph, the information in a graph, we could put both sets of data on one graph. And this is called a kind of a double broken graph or a comparison graph. Okay? And these are often really, really helpful to compare the trends of two different things. So the Regina ones, here's that increase, and then here's the kind of the price leveling out. In Vancouver, here's a little increase, then a little drop, and then the price increasing again. So you can kind of see what's happening there, right? Okay, so that's the graph. What conclusions can you draw from the table about the house prices in the two cities? Well, this is what we had mentioned. They both generally increase. The house prices generally in Vancouver are quite a bit higher, right? Almost 5 times as high. And, there was, I don't know. Is there any other similarities? Between these 2 years, they both grew. I mean, almost the same amount, right? Between these years, Vancouver went down and Regina went up quite a bit. So Regina had its largest growth when Vancouver went down. So I wonder what that would mean. What do you think was happening at that time? Sorry?
People fled Vancouver.
Okay, they fled Vancouver. Maybe there was more houses on the market, and so the average price came down because the demand was a little bit low. And maybe a lot of people moved into Regina, right, around here, and then so house prices, there's not as many houses on the market, more people wanting them, so bidding war, and maybe house prices generally go up. So so maybe there was some migration from Vancouver to Regina here. I don't know. Could the opposite could be maybe true here, right? House prices didn't change, but house prices went up here, so maybe more people moved here to Vancouver in these years. Got sick of the snow, yeah. They're like, what are we doing back in Regina? Oh, goodness. Let's get out to the rain in the winter, not the snow and the cold. I don't know, would you guys rather have lots of snow and cold or rain like every day? Like rain like almost every day though?
Yeah.
In the winter?
Yeah.
Because it's usually not really.
You guys have never lived in rain every day. You don't even know.
I have.
You don't know about.
Oh yeah, oh yeah.
I grew up in Costa Rica.
You grew up in Costa Rica.
Yeah.
You're lying.
I am not.
Yes, you are.
I'm not.
I bet you are.
I actually studied with monks there.
You studied with monks in Costa Rica.
Yeah.
Your nose is getting longer every time you speak.
You get it like Pinocchio?
Like
Oh,
Pinocchio.
I get it.
Well.
I'm just saying, I'm telling you.
Okay.
They're baseball monks.
Okay. See? Lying. Okay. All right, build your skills. Go ahead and build your skills. This is you guys. 9. You guys got it going on here. 10. Okay, so 9 and 10. And that's where we'll stop today and we'll work on this.
Do we have to use our graph papers?